Hello, viewers. In today's class, we are going to discuss yet another important and very conceptual problem from integral inequalities. Right? So, here in this lecture, we'll solve this problem in which we have to show that the value of this integral is less than or equal to pi raised to 5 divided by 160, right? So we have to show that the value of the integral from 0 to pi by 2 x raised to 4 sine x dx is less than or equal to pi raised to 5 divided by 160, right? So let us start. So viewers, in order to solve these kind of problems related to integral inequalities, we have to make use of one important concept, right? And we have already discussed that concept in our earlier videos related to integral inequalities, right? But for the benefit of viewers, let us revise the concept quickly. See, suppose we have two functions, right? Say f of x and g of x, right? And f of x is greater than or equal to g of x in the interval that is from a to b, right? So whenever we have this condition for the two functions f of x and g of x in the interval a to b, then the integral of f of x from a to b is also greater than or equal to the integral of g of x from a to b, right? So whenever f of x and gx holds this inequality, then the integral of f of x and g of x holds this inequality, right? So let us quickly interpret this condition geometrically, right? Suppose we have here x-axis and y-axis, right? And we have the functions, say this is f of x, right? This is the curve which is given by this function f of x, and suppose this is the curve or the function g of x, right? And let us define the points, that is this is the point, say a, and this is the point, say b, right? And between a and b, including a and b, we can easily see that for all values of x lying between a and b, the value of the function f of x is always greater than or equal to g of x, right? So the equality holds when f of x and g of x coincide. So now from the definition of definite integral, we know that this integral, that is from a to b, f of x denotes the area bounded by f of x, x-axis, and here we have the points from a to b, right? So a to b, f of x dx denotes the area. Suppose this is A, this is B, this is C, and this is D, right? So this whole area is denoted by this integral a to b f of x dx, that is area ABCD, right? And the integral a to b g of x dx denotes the area, right? This area we can shade it like this, because this is our curve or function g of x. So this area is given by this integral, that is a to b g of x dx. So we have here, say this is E, this point is E, this point is, say, F, right? So area EF C D, right? And from the figure, we can easily conclude that the area ABCD is greater than area EFCD, right? Area EFCD. And we have already said that the equality holds when the function f of x and g of x coincide. So when the functions coincide, we have the equality, right? So area ABCD is now integral a to b f of x dx, and this is greater than or equal to the integral a to b g of x dx, right? So this inequality shall be used to prove this statement. So now what we will do, we'll start with this function sine of x, right? And see here the limits of integration vary from 0 to pi by 2, right? So our a is 0 and b is pi by 2, right? Now if we see the graph of sine x, and we can see that the graph of sine x goes like this, and here we have 1, this is 0, and this is minus 1, right? And this is pi by 2, right? So at x is equal to pi by 2, the value of sine x is 1, right? So we can start with this statement that sine x is always less than or equal to 1 when x lies between 0 and pi by 2, and which happens to be our limits of integration. So sin x is less than or equal to 1 when x belongs to 0 to pi by 2, right? So all these values are less than 1 or equal to 1, right? So we'll start with this statement, right? Now see, here we have x raised to 4. So what we will do, we'll multiply this entire inequality by x raised to 4, and we can conclude that x raised to 4 is always a positive quantity because this is an even function, right? And when x belongs to this interval, then for all values of x, x raised to 4 is always positive, right? So the direction of the inequality doesn't change, and we can simply multiply both sides by x raised to 4. So what we will get, x raised to 4 sine x, and here we have less than or equal to x raised to 4, because x raised to 4 times 1 is x raised to 4, right? So now see, here we have two functions, and see, here we have f of x greater than or equal to g of x. So we can write this inequality like this, that is x raised to 4 is greater than or equal to x raised to 4 sine x, right? So we have just written this inequality in this form so that we can easily compare this one with this inequality, right? So see, f of x is greater than or equal to g of x. So we can write f of x as x raised to 4 and g of x as x raised to 4 sine x, right? So now we have obtained two functions, right? So whenever we come across with these kind of problems, so our main objective is to get f of x and g of x. So here f of x is greater than or equal to g of x, that is x raised to 4 is greater than or equal to x raised to 4 sine x. So when this inequality holds, then the integral of f of x from a to b is also greater than or equal to a to b g of x dx, right? So integrating both sides with respect to x from 0 to pi by 2, right? So 0 to pi by 2 f of x dx greater than or equal to 0 to pi by 2, and here we have g of x dx, right? Now f of x is x raised to 4. So we have 0 to pi by 2 x raised to 4 dx greater than or equal to 0 to pi by 2, and g of x is x raised to 4 sine x dx, right? So now see, here we have this integral, and here also we have obtained the same integral, right? So let us uh, denote this integral uh, as I, right? Just for simplicity. So here we have obtained, or we have written this integral as I, so we can write it as I, right? So now we have this inequality, that is I is less than or equal to 0 to pi by 2 and x raised to 4, and here we have dx. So now the integral of x raised to 4 is x raised to 5 divided by 5, and the limits of integration are from 0 to pi by 2, right? So this is I less than or equal to, now we can write 1 over 5, and we can simply substitute the limits and we'll take the difference. So we have pi by 2 raised to 5 minus 0. So we have now 1 over 5, this is pi raised to 5, and here 2 raised to 5 is 32. So we have now 5 times 32 is 160. So we have pi raised to 5 divided by 160, right? So this is the desired result. So this is how we can solve these type of problems related to integral inequalities. And here I is our this integral, right? So viewers, this is how, by making the use of this inequality, we can solve these type of problems very easily.